Hello and welcome to a new chapter of mathematics based on three-dimensional geometry. Today we shall be discussing about direction cosines of a line. Later we are going to deal up with the direction ratios of a line. Later we are going to discuss about direction cosines of a line joining two points. And finally we shall conclude this lecture based on three-dimensional geometry by discussing some numerical problems that would be based on the concepts that we are going to discuss in the coming segments of this lecture. Now, a bit of three-dimensional geometry has been already discussed in the previous standard, and today we shall be starting with discussion on direction cosines of a line. Now here we are going to consider this figure. Now if a line L makes an angle of alpha, beta and gamma with the positive direction of the coordinate axis, then these angles, that is alpha, beta and gamma, are called the direction angles, and the cosine of these angles, that is cos alpha, cos beta and cos gamma, are called as the direction cosines of the line L. The direction cosines of a line are usually denoted by L, M, N, where L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Now as we know that there are two angles between two lines, so we have the direction cosines as cos of pi minus alpha, cos of pi minus beta, cos of pi minus gamma. That is minus cos alpha, minus cos beta, minus cos gamma are also the direction cosines of the given line L. Thus the direction cosines of the line are either L, M, N or minus L minus M minus N, where L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Next we are going to discuss the relation between direction cosines. Here let us suppose L, M, N be the direction cosines of the given line L. Then L square plus M square plus N square is equal to unity, that is 1. Next we are going to discuss the direction ratios of a given line L. Now here, if L, M, N are the direction cosines of a line L and lambda is any non-zero real number, then lambda L, lambda M, lambda N are called as the direction ratios or direction numbers of the line L. Thus, if A, B, C are direction ratios of a line L, then A is equal to lambda L, B is equal to lambda M, C is equal to lambda N for some non-zero real number lambda. Now since lambda is any non-zero real number, it follows that there are infinitely many sets of direction ratios of a given line L. Now if A, B, C are direction ratios of a line, then its direction cosines are either A divided by root of A square plus B square plus C square, B divided by root of A square plus B square plus C square, C divided by root of A square plus B square plus C square, or minus of A divided by root of A square plus B square plus C square, minus of B divided by root of A square plus B square plus C square, minus C divided by root of A square plus B square plus C square. Next we are going to discuss the direction cosines of a line joining two points. Now here let us suppose 2 points to be P and Q, with P having the coordinates as x1, y1, z1 and Q having its coordinates as x2, y2, z2. Then the direction cosines of a line joining the 2 points are given as x2 minus x1 divided by modulus of pq, y2 minus y1 divided by mod of pq, z2 minus z1 divided by mod of pq. And the direction ratios of the line joining the 2 points, that is P and Q, are given as x2 minus x1, y2 minus y1, z2 minus z1. Next, we are going to discuss a problem based on finding the direction cosines of a line joining two given points. Now we have a problem that states that a line passes through 2 points with point 1 having the coordinates as 6, -7, -1, and the second point has its coordinates as 2, -3, 1. Find direction ratios and the direction cosines of the line so directed that the angle alpha is acute. Now, as discussed, direction ratios of the line joining the two given points, which are 6, -7, -1 and 2, -3, 1, are 2, -6, -3 plus 7, 1 plus 1. Now, these points are obtained by using the formula of the direction ratios, which gives us the value of the direction ratios as x2 minus x1, y2 minus y1, z2 minus z1, where x1, y1, z1 are the coordinates of the first point and x2, y2, z2 are the coordinates of the second point. This gives us the value of the direction ratios as -4, 4, 2. Or we can rewrite the direction ratios as -2, 2, 1. Now, since we have already discussed that the direction cosines are given as x2 minus x1 divided by mod of pq, y2 minus y1 divided by mod of pq, z2 minus z1 divided by mod of pq, where p and q represent the two given points having the coordinates as x1, y1, z1, x2, y2, z2. Thus, we have the modulus of pq as root of -2 square plus 2 square plus 1 square, which gives us the value of modulus of pq as 3. Thus, using the above formula, we have the direction cosines as either -2 by 3, 2 by 3, 1 by 3, or 2 by 3 minus 2 by 3 minus 1 by 3. But the line is so directed that the angle alpha is acute. That means cos alpha is greater than 0, which means that L is greater than 0. Therefore, direction cosines of the line which is so directed that alpha is acute are given as 2 by 3 minus 2 by 3 minus 1 by 3. Thus, the direction cosine of the given line formed by joining the two given points is given as 2 by 3 minus 2 by 3 minus 1 by 3. With this, we conclude the first lecture based on three-dimensional geometry, in which we have discussed about direction cosines of a line and direction ratios of a given line.